So we've gone over solving systems of equations by graphing, substitution, and elimination. Now, here comes the question of when do I use substitution and when do I use elimination? So we're going to go through how we can determine when to use each method. So first, substitution we usually use when a variable is already isolated or when you can easily isolate a variable. So if you look at the example, it already has x equals 5 minus y. So since x is already isolated, you can easily substitute 5 minus y in for x and solve. When doing system by elimination, we usually like to use this method when none of the variables are isolated and it's when it's a little bit difficult to do so. So for example, although these two examples are fairly easy to isolate a variable, this is kind of just demonstrating how we would do so through elimination. If you notice, we have x plus y equals 2 and x minus y equals 14. You have a positive 1 and a negative 1 in front of your y value, and we know that these are additive inverses, which end up equaling 0. Therefore, we can eliminate the y variable. And this allows us to solve for x and then substitute back in to find our y. So just to kind of go over that again, we normally use substitution when a variable is already isolated, and we normally use elimination when none of the variables are isolated, or when it's difficult to isolate a variable. So now we're going to go into elimination. We've already done solving systems by elimination, but we have not done it where we would have to multiply both equations by a number in order to eliminate a variable. We know our goal in elimination is to have the coefficient of either the x value of the x variables or the y variables to be additive inverses. If you see on the right hand side here, it gives us an example of our additive inverses. It's when we have the same numerical value, but one is positive, one is negative, because they end up being 0. So if we look at the example we have here, negative 5x plus 5y equals negative 25. We also have 3x plus 2y equals 10. Now if you look, we cannot multiply 3 by any number to give us a 5. We cannot multiply 5 by any number to give us a 3. And same goes for the y's. You cannot multiply 2 by any number to get a 5, and we cannot multiply 5 by any number to get a 2. So this is a case where we would need to multiply both equations by a number in order to create additive inverses for either the x or the y's. Now I'm going to show you how to do it with both the x and the y's. First, we'll start off with the x's. So to go through that, we want to look at what the least common multiple is between a 5 and a 3. So if you think about that for a minute, we know that 5 times 3 gives us 15, and 3 times 5 gives us 15. So we're going to multiply our first equation by 3 to give us a 15, and we'll multiply the second equation by a 5 to give us a 15 in front of our x. Now if you notice, we multiplied the second equation by the coefficient of the x in the first, and we multiplied the first equation by the coefficient of the x in the second. So let's rewrite our equations. I'm going to move down. We're going to do it over here so we have some more space. So we said we're going to multiply this one by a 3, and we're going to multiply this one by a 5. And if you notice, there was already a negative in front of the 5 in the first equation. This means that when we multiply or use our distributive property, we are going to have additive inverses. Now let's see how that's going to work. We're going to distribute. Okay, so now we're left with, use a different color here. We have negative 15 negative 15x plus 15y equals negative 75. And then our second equation becomes 5 times 3x. We get positive 15x. 5 times 2y is 10y. And 5 times 10, we get 50. Now, what do we notice about our x variables and the coefficients? That we have additive inverses. We have a negative 15 and positive 15. And we know when we combine them, we will get 0. So therefore, they are eliminated. So let's carry on. We have 15y plus 10y. We get 25y. And negative 75 plus 50, we get negative 25. So to solve for y, we need to do the opposite of multiplication. We divide by 25 on both sides. And we're left with y equals negative 1. Awesome, awesome, awesome. Now, we need to find our x. I'm going to write out, I think I have some space over here. I'm going to write out our solution. Our y is negative 1. Okay. Now, we need to find our x. So even in elimination, that second step is always going to be to substitute back into one of the originals. So we are going to choose, I'm just going to choose the second equation. We're going to rewrite it. 3x plus 2y equals 10. We know our y is equal to negative 1. So we're going to substitute 3x plus 2 times negative 1 equals 10. 3x minus 2 equals 10. Add 2 on both sides. We're left with 3x equals 12. Divide by 3. Divide by 3. We're left with x equals 4. Awesome. Oops. So our x is going to be equal to 4. And this would be our solution to the equation. Okay? So now, I'm going to show you a different way to do it. Through eliminating the y values. Alright, so here we go. Same thing as before. We're going to multiply each equation by the coefficient from the opposite equation. So what I mean by that is, first equation, we have a 5 and a 2. So what we're going to do is we're going to multiply the first equation by the 2. We're going to multiply the second equation by the 5. Because we know that 5 times 2 gives us 10, and 5 times 2 gives us 10. So now the only thing else we need to look at, is the fact that both of these are positive. So that means if we were to get 10 and 10 in front of our y's, we add those and we get 20y. That is not eliminating. Eliminating means we need to cross them out, and in order to cross them out, they have to equal 0. So what we need to do is make one of them negative. Does it matter which one? No, it does not. So how we're going to do this, choose either the top first equation or the second equation. We're going to multiply by a negative. I'm going to choose that first one. So we're going to rewrite the equations. So we have negative 2 times negative 5x, we have 10x. Negative 2 times positive 5y, we have negative 5, negative 10y. And then we have equals positive 50. All right. And I don't need that positive there. Now in the second equation, let me draw my other arrow. There we go. We need to distribute the 5. So 5 times 3, we get 15x. 5 times 2y, we get positive 10y. And then 5 times 10, we get 50. Alrighty. Now, we got to figure out. We said we were going to eliminate our y's this time. Let's see. Will they end up canceling out? Did we do it properly? Negative 10, positive 10. Yes, we did. Cancel out. Let's use a different color for the next step. Let's do green. 10 plus 15, we get 25. Equals 100. Get x by itself. We divide by 25 on both sides. We're left with x equals 4. All right, we're getting there. X equals 4. We'll write our coordinate down here. All right, now we're missing our y. So what do we have to do? Plug into one of the equations, and I am going to choose the second equation. Actually, I'm going to choose the first one since we haven't used that one yet for substituting back. Let's do this. So we found our x equal to 4. So here's our x. Now we can substitute that for negative 5 times 4 plus 5y equals negative 25. Negative 5 times 4, we get negative 20 plus 5y equals negative 25. Upside down t, opposite of subtracting 20, add 20. Left with 5y equals negative 5. Divide by 5, divide by 5. And we're left with y equals negative 1. Awesome sauce. That looks orange. All right. So we're left with 4 comma negative 1. Very good. And if you notice, we got the same answer, which means it doesn't matter which variable you eliminate. So just to briefly go through the steps we did. First, we identified which variable we wanted to eliminate. Then we multiplied the first equation by the coefficient of the variable in the second equation. Then we multiplied the second equation by the coefficient of the chosen variable in the first equation, right? Because we multiplied 5 by 2 and we multiplied 2 by 5. Then we eliminated one of the variables and solved for what was left. Then once we got our x or y value, we substituted back into one of the original equations to find our other variable. And then we have to make sure we write our solution as a coordinate x comma y. So really quickly, I just wanted to show you. Here we go, Desmos. That when you type in the equations into Desmos, negative 5x plus, plus 5y equals negative 25. There's the first equation. Second equation, 3x plus 2y equals 10. Now I want you to look at this graph really quickly. Let's look at where these two lines intersect. That coordinate is 4, 1, which is what we got as our solution. So remember, our solution is where our lines are going to intersect on a graph. Well done, everyone.